Okay, so this is with the last handout about definite integration. So it talks about the area between a function f of x equals 10 plus 8x minus x squared, and the vertical lines x equals 1 and x equals 7. So this is just to reiterate that the definite integral is an area underneath the curve. It's going to be some kind of a inverted quadratic or parabola. So when it says find the area, that just means that we need to evaluate the integral from x equals 1 to 7 of 10 plus 8x minus x squared dx. Now sometimes people they get too used to u substitution and they think everything has to be u substitution, but you only use u substitution when the original integral is not integrable using the standard techniques, which in this case it is. It's just a polynomial. So we're not going to have to do any u substitution or anything like that. We're just going to integrate it. So the integral of 10 is 10x. The integral of 8x is going to be 4x squared. So you get the integral of x is x squared divided by 2. 8 divided by 2 is 4. And then you'll have x cubed divided by 3. Because it's a definite integral, I'm just going to draw these vertical lines. So that means we want to evaluate this at the upper limit and the lower limit. So we've got the upper limit, we have 10 times 7 plus 4 times 7 squared minus 7 cubed over 3. So that's the upper limit. And then you're going to subtract it, evaluate it at the lower limit. So let's go ahead and multiply these out. So 70 plus, okay, you'll have 47 squared, which is 49. 49 times 4. 49 times 4, which is 196. Then we have 7 cubed, which is 343 over 3. So that's my upper limit. And then my lower limit is going to be 10 plus 4 minus 1/3. Now because I've left these as fractions, I should be able to kind of clean things up pretty easily. So what I'll do is I'll do the whole numbers first. So you'll have 70 plus 196, subtract 10 and 4, so I'm subtract 14, and so I'll get 252 minus 343 thirds, and here I have a negative plus 1/3, so that's going to be 252 minus, so we have negative 342 thirds, and you can divide that by 3. 342 divided by 3 is 114, so we get 252 minus 114, which is 138. Okay, so I'm going to pause for just a second to make sure that's right before we move on. Okay, so that's right. So that's the first part. We're going to use the same equation. It says calculate the average value of the function from over that interval. So to calculate the average of something, so let's call that, how do we define that? F of x. Yeah, so the average value of the function, I'll say just f average. That's 1 over b minus a times the integral of f of x dx from a to b. So I've already done the second part. So all I have to do is divide 1 divided by 7 minus 1. Those are my limits, times 138. So 138 divided by 7 is 138 sevenths. Do it as a decimal, 19.7. So that's the average. It says at what value or values of x does the function equal the average value? Okay, so there's one that's a little more difficult. So what you have is the average value is equal to, then you have the function, which is 10 plus 8x minus x squared. So the question is, what values of x does the value of the function equal the average value? So what we can do is let's move everything to one side. So we'll have x squared minus 8x. So move those to the other side. And then we have the constant parts, which we've got 19.7 minus 10, which is plus 9.7. Obviously, I'm going to have to use the quadratic formula. So it says x equals minus b plus or minus the square root of b squared minus 4ac over 2a. For our particular case, a is 1, b is negative 8, c is 9.7. So we get negative 8 plus or minus the square root of negative 8 squared minus 4ac over 2 times a. So you get x is equal to 8, negative and negative, plus or minus the square root of whatever I've got in there, which is 64 minus 4 times 9.7. So 25 square root of 25.2 over 2. So 8 plus the square root, 25.2, the whole thing divided by 2. I get 6.51, and 8 minus the square root of 25.2 divided by 2, which is 1.49. So let's plot this function and see if this all makes sense. I want to pause it just a second while I get the graph. Okay, so here's the function, or here's the graph. So my graph is going to be 10 plus 8x minus x squared. And let's just show it from 1 to 7. And I graph that. And let's see what happened. There it is. Okay. So I just want to get that right now. Now I'll change the limits back again. 1, 2, 7. Graph. Okay, so we know the average has to be somewhere between here, which is 17, and here, which is 25. So somewhere between 17 and 25. And what did we get? The average value was 19.7. So that makes sense. Let's just plot horizontal line of 19.7. Doesn't look quite right. So that's because you should have just as much area above the curve as below the curve, and it looks like there's more above the curve than below the curve. So that indicates that I made a mistake somewhere. So again, I could re-record all this stuff, but I'm trying to give you some tools here how to handle these kinds of things. So let's go back and look at the function, see why I got the wrong answer. So did I divide by 7 or 6? 138 divided by 6. There we go. So that's the problem. This is, I should have divided this by 6 instead of 7. So we get 23, which means all this stuff's wrong too. So 23. So we'll have 23 minus 10, which is 13. Put that in there. Plus 13. This is 13. 13. So what we have, square root of is 64 minus 4 times 13, 12. Okay, so I get those, fix those as well. So you have 8 plus the square root of 12 divided by 2, 5.73. And minus the square root of 12 divided by 2. There we go. 2.27. Okay, so let's go back to the graph again. So what we're going to do is we're going to put a horizontal line at 23 instead of 19.7. Okay, so that makes more sense. You can see this area here and this area here should be the same as the area in the middle. So I think that's a reasonable expectation. And the next question was, at what values of x does the value of the function equal the average value? Well, that's actually these points of intersection. So if I zoom in on this, I'll get x equals 2.27, and there's that solution. And then we can zoom out. Let's see, how do we undo here? Okay, and then we could zoom in over here, and the x value is 5.73. 5.73. So there we go. So now we know it's right. Okay, so that's the last one. So what we learned is, the area underneath the curve is the definite integral. You can find the average by taking the integral between two limits and dividing by the difference in those limits. And there should be some values, this intermediate value theorem, where the value of the function equals the average value. Let's just see if we can do a quick estimate. This area, 138. So if we go back to this curve and we look at the area under the red curve. So each one of these is 5 by a quarter. So it's 5 quarters. So then we'll count how many boxes we have. So each square is 5 by 1/4, and then we count how many boxes we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, we just don't need to count them. There's 7. 7 times 4 is 28. So 28, let's add these together. 28 plus another 28, that's the next row, plus another 28, that's the next row. This one, there's almost 28, so let's say that this little bit on the bottom is about this much on the top, so we're going to have another 28. And then, so that's this row, and then here we're probably going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to say, I think this is the center. 3.5 would be the, no, 3.75 would be the center. 4 would be the center, yeah. So we'll just do some symmetry here. So we'll say 1, 2, 3, 4, 5, 6, 7. 7 and a little bit, so multiply by 2, so I'll say 15. So 15 and another 15, so I had 4 rows of 28, 1 of 15. I got 127. And so if you take 127 times 5 divided by 4, I think I might have overestimated here. 159. Okay, I just thought to see what I get. Okay, so that's it.